and welcome to AWS Tech Talks. In this session, we're discussing using the AWS Serverless Application Model to build serverless applications. My name is Eric Johnson. So who am I? Well, like I said, my name is Eric Johnson. This roughly looks like me. You can find me on Twitter at EDJGeek. Feel free to ask me any questions. I try to help as much as I can. I'm a principal developer advocate for AWS Serverless here at AWS. I am a serverless tooling automation geek. I've been doing it for a long time and I love it. I've been a software architect, solutions architect for 25 years, really more than 25 years, but that's all I care to admit to. I'm pretty old. And I'm a husband and a father and a drummer. This used to say musician, but a lot of people push back on that, so maybe just a drummer, but any way you want to look at that. So today, this is our agenda. Now, before we go through the agenda, I do want to tell you straight up that we have a lot of information we're going to cover in this hour, and I'm going to move pretty fast. So I apologize up front. Hopefully, it's at a pace that you'll be able to keep up. However, we have an excellent Q&A team that's going to be helping to answer these questions as you have them. So feel free to ask questions in the Q&A window. Also, at the end, I'm going to be giving you resources to go and dive deeper into a lot of the concepts that I'll be talking about. While this is somewhat of a deep dive into the ins and outs of SAM, a lot of it will be concepts, and I'll give you a pointer to dig deeper into that. All right, so with this, we're going to talk about the agenda, which is we're going to do, first of all, an intro to AWS SAM. What is it? What is AWS SAM? We're going to talk about AWS SAM transformation, building reusable templates, the AWS SAM CLI, and a new beta software or features out called AWS SAM Accelerate. So let's jump in. So as you've probably surmised, serverless application or SAM. This is our squirrel here. If you've seen any tweets or videos, sometimes every once in a while you'll catch me in a squirrel costume. There it is. I don't know if I'm proud about that or not, but there it is. So the serverless application model comes in two parts. First is SAM Transform. This is the templates that allow you to do shorthand syntax to express resources and event source mappings and a lot of other, properties in this. It provides infrastructure as code for serverless applications. The SAM CLI provides tooling for local development, debugging, build, packaging, and deployment for serverless applications. And really it does a lot more, and we'll climb into that, especially when we get into SAM Accelerate. All right, so the SAM Transform. So let's take a look at a SAM template. This is an example of a SAM template. It's just got 20 lines. And in this SAM template, I'm creating two resources, an AWS Lambda function, you can see that at the top, and an Amazon DynamoDB table, you can see that at the bottom. But as part of the AWS function, I'm also creating the AWS IAM role and an Amazon API gateway. And these are, as you see, the policies that I'm creating. SAM will create the default policies as well as any you add here. And the event source generates whatever it is we're using as an event. So what happens is these 20 lines of code become your infrastructure. And here you see the API gateway, you see a Lambda function, you see a table, and then the role that's wrapped around it. And this role, the first role allows Amazon API gateway to invoke Lambda function, and then there's a role that lets Lambda function talk to the tables or credentials. So now, AWS SAM is built on top of AWS CloudFormation. It's literally an abstract that sits on top of it, right? So when you're using SAM resources, you can also use CloudFormation resources and they'll work just fine. So let me show you what that means. Back to our SAM template. So here in our SAM template, we've got our 20 lines of code. When we do a deploy, whether it's in the console or with SAM, but when we take a SAM template, we deploy it, that second line in the SAM template that says transform tells CloudFormation, hey, I've got some special resources in here that I need you to transform to actual CloudFormation resources. And what happens is you end up with a template, and in this example is 188 lines. I shrunk that down pretty good, but you're not going to see them all. But it breaks it out. You have your Lambda function, you have your roles, you have your DynamoDB table, you've got different parts of the API gateway, and that's all handled for you in the background. All right, so with SAM, there are 7 serverless resource types. So these are special resources, like I said, that expand to normal CloudFormation resources. And we're going to walk through them. So the first one we have is the serverless function, right? And so this is an AWS Lambda function. And in this, you can put the description, you can say the code URL, where the code's going to live, the app handler, or the handler in the app.handler is what is invoked when the Lambda function is run. The runtime, memory, timeout, all the settings that you would set this up, as well as, like we talked about, other things like policies, environments, and events that generate other resources to fill out your application. Now, one thing I want to point out here, and this is brand new, is there's a new parameter inside of the serverless function setup, that's the architectures flag. Architectures allows you to choose either x86, which is default, or ARM64, which is the new Gravitron support. So with ARM64, you can put that in there, and that'll change it. Now, you can't do both. It's one or the other. So just be careful with that. But if you don't put an architectures parameter in here, then the default is x86. So we talked about how in the Lambda configuration, you can create event sources or connect to event sources, one or the other. And there are 16 function event source types supported in SAM, from S3 to Amazon MQ, right? And each of these are contextually configured. S3, you can connect it to the bucket, to a bucket you're creating inside of the same template. DynamoDB, you can connect to an existing DynamoDB or create the TDB. All kinds of settings you can do here. Also, with the policies, when you're setting up the credentials for the Lambda function, I said that SAM would build a role based on the policies that you put in. And best practice is to start here. Now, there's multiple ways of creating the credentials and policies for a Lambda function. And what you're doing here is you're telling the Lambda function what it's able to do. What is able to invoke the Lambda function is automatically handled by SAM depending on what the event source is. But this policy is saying, here's what the Lambda function is able to do. And you can see in here some of the examples are S3 write, S3 read, DynamoDB configure. There's all kinds of things that you can do. But again, the best practice is to start with these policies, and you can find them at s12d.com/SAM policies. So let me show you what those look like. If you pick one, in this particular example, it's going to be a DynamoDB CRUD. If you pick one, it'll show you what the permissions are to be applied. And some maybe you can see the three dots. I've taken some of them out because to fit everything. But then it also is the resource they are applied to. Now, how this works is in your SAM template, you're going to say, here's the policy I want. It's just that name of that policy, DynamoDB read policy. And you say the table that I want it to apply to is the product table. And this table will be created further down in the template or a table name you may have already. But the idea here is this is a very granular least privilege permissions. It says only this Lambda function can read from only this table. Not everything, not write, not scan, not create a table, not delete a table, but just read this specific table. And that's where we want to start, right? We always start with least privileges, and these policies will help you do that. And the nice thing about these is they work with the Lambda functions. They also work with state machines, which we also call step functions. And we'll talk about that in a minute. One other thing about the Lambda function to understand is how the Lambda function can be built. So later we'll talk in SAM, the SAM build process. And if you don't put any kind of build process, then it'll automatically build according to its runtime, right? So if it's Python, and you may be saying, hold on a minute, Eric, I don't need to build Python. It's already there. And that's true. But this will actually make sure you have all the dependencies, copy, get rid of things that aren't needed, and it basically packages the artifacts. However, if we were using a Java or a .NET runtime here, then it would actually do a compilation process. Option 2 is you can use a Makefile. So I can put in here for my metadata, I want to put a build method, and I'm going to choose Makefile. And that actually allows you to build your own Makefile to do whatever you need to do. And I have an example of that at s12d.com/custom build. And this shows you how to do Webpack with a Node application. All right, so the next resource we're going to talk about, really the next two resources because they're very similar, are API and HTTP API. And these are both versions of API Gateway. And the nice thing about this, you see here, the AWS ::serverless ::API as the type. This will create a REST API on API Gateway. And the bare minimum is really you just need a stage name and a definition URI. And the definition, how you doing? The definition URI points to an API.yaml file, which has an open API. And you don't have to do open API. You can declare more things in the same template. But using open API allows you to manage your APIs in a way that's migratable, and also kind of a cheater here. If you want to go to, cheater is probably not the right word, but you can go to the API Gateway console in AWS and build out exactly what you want and then export that as an open API template and then just put it in your API.yaml file or whatever you name your file. And there you go. You have a full configuration for API Gateway. The HTTP API looks very similar. Again, I'm passing a definition URI because this works with both of them. In this, I show an example of setting up the CORS configuration. That's also something you can do and will need to do as you're setting these up. So again, both API and HTTP API, very similar, and you can use OpenAPI to define these resources. The next one we're going to talk about is a simple table. Now, simple table is not a brand new database. This is just Amazon DynamoDB. And it's an easy way with just 2 lines to create a DynamoDB table that you can read and write and do whatever based on your permissions. Now, this creates a DynamoDB table with one primary key, and it's called ID. It has dynamic capacity, and it uses AWS to manage the encryption. If you need a little more, you can do that in the simple table. You can change the primary key name. Instead of ID, maybe I want to put PK here, something like that. I can change it from a dynamic capacity to provision capacity. Like I said, I want to read and write of 5. I can add some tags. If I need anything beyond that, well, then I can just use the AWS DynamoDB table resource, which is a standard CloudFormation resource. And then I can add my secondary keys and my time to live settings and whatever else I want to do. So again, you're not bound to just using these special serverless resources. They just make life a little easier for you. The next one we have is the LayerVersion. And the LayerVersion has to do with Lambda layers. If you're not familiar with Lambda layers allow you to store your dependencies for a Lambda function outside of the function itself, and they're pulled in as a layer at deployment time. And this is great because this becomes handy if you want to share the same dependencies across multiple Lambda functions within the same application or within the same organization or even publicly. Maybe you have a layer that you've built of an application that you want to let other users. And so you can add a permissions to this that allows anybody in this to read this. Now they are region specific, so you would have to build one for each region, but that's easy to do. This here, because it doesn't have permissions, it'll be scoped to just the application that it's in, so any Lambda function within the application has the rights to pull this in. Just like a Lambda function, with the layers, you can set the build method and build as you'd like to do. So the next resource we have is the serverless application. And the serverless application allows you to really break down your application into simple chunks that you can kind of manage templates with. It allows for nested applications. In this example, and this is true to life, I have an application that's my auth app. And in that auth app, I have a full Cognito setup with custom domains and hosting and all that kind of stuff that I can plug in anywhere. And then it'll hand out to me a JWT token if I'm using HTTP API or a Cognito authorizer token if I'm using REST. And I can reuse it in as many applications as I want. And this is great if you have an application, let's say you have like an image processing that you do internally, you can have that as a secondary or as a contained app that other people can pull in with this. So what you do is you declare it, you set the location. The location could be a local file on your computer, it can be on a network, it can be in an S3 bucket somewhere. And then you can pass in parameters. In this particular one, I need a domain name. So I tell it, hey, this is what I want you to call the auth domain. And so that allows you, and when this deploys, it'll build out nested stacks. All right, the last one we're going to talk about is a StateMachine, also known as AWS Step Functions. AWS Step Functions doing some really great things, and you can build these right within SAM. Now, notice here in the SAM template, I have a definition URI here as well. We remember that from API Gateway. Well, yeah, it's the same idea. I can store the configuration of my state machine in an external file called the .asl.json file. ASL, if you don't know, stands for Amazon States Language, and this is a declarative language that allows you to build your step functions. Then you can add a role, says this is the role that the step function will use, this is where all my permissions are. And then you can do definition substitutions. And these are ways of, let's say I have a function called an error function. And I have a table called product table, and I need that information, the ARN for it and the name for the table, inside of the ASL file. Well, I can pass those in as definition substitutions, and inside the template, I just use the $ and curly bracket and wrap around the name, and I'm able to get the error function's ARN or the table's name. And of course, you have a step function that's built out. Really handy. And again, just like API Gateway, what I tend to do is if I'm going to build a step function, if I'm doing a proof of concept, I'll go to the console. I'll use the new Workflow Studio, which is fantastic. I'll build out my proof of concept, and then I'll export that ASL, and then I'll drop it into SAM and SAMify it by making it dynamic with the definition substitutions and limiting the roles to only permissions it needs, or I'll use the policies like we talked about with the Lambda function. All right, so that's all of the specific serverless resources that come with SAM, right? Again, I want to remind you that you can use any CloudFormation resources as well. I want to talk about one other section of the template before we move on. And this is the Globals section. And the Globals section allows you to kind of, again, minimize lines of code inside your template. So let's say I have a cat function. In this cat function, I'm declaring the code URI, the handler, runtime, memory, timeout, all the things, right? Events, layers, everything. But I also have another function called a dog function. And the dog function, really the only difference between these are the code URI, the name of the event, and the path of the event. Everything else is pretty much the same. So instead of duplicating this all the way through, I can create a global section in the root of my template. And that global section applies to multiple things. You can do API, you can do function, and in the function section, I can say every function in this template will have a handler of app.handler. Every function will have a runtime of Python 3.9. Everyone will have a memory of 1024, timeout of 15 seconds, and so on and so forth. And then you can see the cat function is much shorter and the dog function is much shorter. However, notice in the dog function, I have a timeout of 30. And I can do that because the local parameters will override the global parameters. So I can set them by default in the globals, override them at the specific function. And so I have flexibility to set this up. All right, let's move on. So the next thing we want to talk about is building reusable templates. Now, building reusable templates, why would we want to do this? Well, we want one source of truth for our infrastructure. When we look at best practices for how our development cycle should run, first of all, we recommend that each developer have their own account. And so we don't have to do, special namings of functions and aliases and versions and all that stuff. They just simply have their own account where they can deploy their stack for testing purposes. Every environment should also have its own account. Beta should have its own account, and production should have its own account. And one thing you're getting out of this already is inherent security. Only people who can deploy to production should have access to the prod account. Only people who can deploy to beta should have access to the beta account, and so on and so forth. So that's your first layer of security, right? And when we look at this, we go, okay, well, that's great, but if I have one template, the parameters that I'm going to use, endpoints might be different per environment, or secret keys or different things like that. Well, we have a plan for that. There's a couple of ways you can deal with that. So the first is just simply parameters. Parameters passed into the SAM template at the time of deploy, and you can do this, as a different file for each environment or something like that. Now, straight up, don't store keys in here. Okay, these are public. You're saving it somewhere. This is not a place for secret keys. This is a place for just simple configuration. Now, these can be strings, numbers, lists, common delimited lists, specific parameter types. You can use AWS SSM or AWS secrets, and the reason you can use that, and you're like, Eric, you just said don't do secrets. Don't pass in secrets, but you can resolve secrets, and let me show you what I mean by that. So in this, I use several different types of variables. Let's say I have a variable called DB engine that I pass in. Now, DB engine's not secret. I don't care. You can know what DB engine I use. So in order to use that, I'm going to reference just the DB engine passed in. Yeah, I also have a DB version and a DB name. And these aren't highly secret, but I want to keep them somewhat secret. So I can store these in the parameter store, the SSM parameter store, and actually on the DB version I'm saving there. And so to resolve that, I can just, and it looks just like this, in single quotes, curly Q, resolve SSM, and then a link to the, or a path to the actual one and the version you want. For Secrets Manager, you can resolve Secrets Manager, my app, and DB name, but that's not encrypted. If I have an encrypted one, which are the next two, the username and the password, I can still resolve from the Secrets Manager, do the path to it, and then I tell it it's a secret string, and then the username, and the same with password. But my user has to have the rights to decrypt that and to use that. So that's when you're deploying these, the user deploying this has to have the rights to do that. Now, I talk a lot more about, there's a lot we can talk about parameters and different ways of doing that. I cover a lot of this in an episode of Sessions with Sam, which I'll talk about later. But this is s12d.com/secrets. If you want to know how to kind of store those, I suggest you watch this. So the next way you can make templates dynamic is through pseudo parameters. And this allows you to grab dynamically. It'll happen at the CloudFormation level. You can grab your region, the account name, special value for no value if you're doing a condition where you want to say either this or nothing, those kinds of things. So pseudo parameters are super helpful for that. And the other one is intrinsic functions. And these are actually functions where you can do conditionals. You can evaluate, does this equal this? Is this and this? We already saw it quite a bit down the bottom right there, the ref statement. And we're able to reference something else in the template, or with a function import value, you can reference something from another template if it's exported. So there's a lot of control here. You can do string manipulation. So don't be afraid to use these functions to dynamically build the data you want. Let me show you what that looks like. So in here, on the first one, I need to create an endpoint, and I show the endpoint that we use for API gateways. This is the one that's assigned. And so I can build this by putting together the serverless HTTP API, I reference that, and then the AWS region. Now, I'm using a substitute function, and the substitute function in SAM, I don't have to do, if I just do the $ curly Q and a name, it's automatically going to look for either a parameter passed in or the result of a ref value on one of the other resources. And for HTTP API, that will always be the ID. So I can also create conditions. In this example, I pass in a domain name and a zone ID, and then I create a zone ID, and I say bang equals. Now that's not equals. Bang is the shorthand for using these functions in YAML for SAM. But I'm saying bang equals, and I'm saying I want the ref zone ID to equal none. If it equals none, then I need to create the zone. And so you can see over here on the right, the top one, I have a generate zone resource where I actually do it. And right on the root of that, I do a condition. I say, if I'm supposed to create the zone, then create the zone. And then below here on HTTP API, I can also use that condition further down or further into the subject here under hosted zone ID. And I say, if create zone, then grab the reference of that zone that was created. If not, then grab the one that was passed in. So I have a lot of power that I can work with conditionally there. All right, so that covers the transform. And now we're going to drop into the AWS SAM CLI. Right, and the AWS SAM CLI, again, like we talked about, is a tool for local development, debugging, testing, deploying. It supports API gateway, proxy style for testing. You can grab logs from live functions, and it'll help you build in native dependencies. And you can learn more about installing this at s12d.com/SAM, but we're going to talk quite a bit about it now. What we're going to do is we're going to walk through some of the functions that come with it. And the first one we'll look at is SAM init. Now, SAM init, SAM initialize, creates a new serverless application. And you choose the runtime, dependency manager, if that's available. For instance, with Java, you can do Maven or Gradle. The output directory, by default, it'll create a directory by the name of the application, but you may want it somewhere else. Name the application, and then location. And let me talk through this in a SAM init, and that'll make more sense on the location in just a moment. So when I do a SAM init, the first thing it's going to ask me is, which template source would you like to use? Would you like an AWS Quick Start template, which we have a bunch of managed ones, or do you have one you'd like to use? If I hit a 1, then it moves on like you see it shows here. If I hit a 2, then it's going to ask me for a location of that template, and it can be a zip file locally, it can be the root of a GitHub directory, it can even be an S3 bucket with the zip file in it. And what it'll do is it'll copy that template and give you a starter. But most of the time we use AWS Quick Start templates, and when you're first starting, I would encourage you to do that. And then it'll ask you, what package type do you want? Do you want them zipped as a zip image or as a image, container image? Both work. Then you choose the runtime, and this example I'm choosing 2, which is Python 3.9. Then I name the project, and then it grabs the templates if they don't exist, and you can choose which of the AWS managed template you want. And this I'll choose Hello World, and then I hit enter. And then what it's going to do is it'll actually show, all right, you have an app named Demo App. It's going to be Python 3.9. Your dependency manager defaults to pip. The application template is a Hello World template, and the output directory is the root you're in. And it tells you the next one that you can read. So when that's exported, then these are your results, right? And so for a zip file, it's going to have, you have your README template, events for testing, Hello World contains the application code, and then the template, which we've been talking about the template for the last 20 minutes, and a folder of tests that can be run. For an image or a container-based Lambda function, the only difference is you're going to have a Docker file. Right, and so that Docker file is how it's built, right? So that's what SAM init does, and it'll walk you through setting that up. Earlier we talked about architecture, how you can do ARM or x86. If you do SAM init dash A or dash architectures, you can then declare, or you can just add it after the fact as a parameter. So the next function we're going to talk about is a SAM build function. This does a lot, and we can't cover everything, but again, I'll have resources. This generates your deployment artifacts targeting your Lambda's execution environment, and it can, it uses container to compile it. It can compile already. It can handle zip files or container files, and it doesn't upload anything. It just downloads everything you need, and it creates everything local, getting ready, and it produces those artifacts. And again, like I said, you can use, this is where that build method, either the runtime or the Makefile, and if you do a Makefile, you can control that. So what does that look like? On the left side, I do SAM build, and it's going to grab the runtime. It's gonna build. I just have one function in this. It copies the dependencies, it builds it out. And then it says here's the export. It's ready to be tested. You can run SAM local invoke for that, or you can do a SAM deploy. For containers, really the only difference is now it's going to download any containers that are referenced in the Docker file to make sure everything's ready. It will build the image, and then it'll tag the image. It also grabs the dependencies and build all the dependencies in the image. And then much like the image, you can do a SAM local invoke or a SAM deploy. Now, I told you what's SAM build. We had this example, s12d.com custom build. It's really kind of this simple. So if I set this to build with a Makefile, then the standard is you do build dash and the name of the function, and that's what the custom build will see. And then I just have it doing a webpack on my code and then copying the code into the artifacts directory. You can do a lot more than that. We have another example where we actually are building Swift, using Swift for backend on Lambda functions, and it's all being done with custom builds as well. So the next function we're going to talk about is SAM package. You may not use this one as much, depending on what you're using SAM for, but this package is the SAM application. So whereas build creates all the artifacts, SAM package puts it all in place, getting ready for a deploy, but doesn't actually deploy. Right, so for as for artifacts that go into S3, it copies those up. For artifacts going into an EC2 repository, it copies that up. In fact, let's take a look at an example. With this, when I hit SAM package, in this first example, I pass in the bucket I want the artifacts to go to, and then I give it an output template file. I'm going to go back for a second because you can see here where I say it outputs a YAML file with updated code URI addresses. So your code URI at first is pointing to a local folder. It says, look, all my stuff is in this local folder. But now that we've packaged it and got it ready for deploy, now it's going to live either in an S3 bucket or an Elastic container repository up on ECR. So we run this, and you can see where it successfully packaged the artifacts and wrote output template with all the updated addresses, and then it gives you, hey, here's how you deploy it. With SAM package for image repository, if image-based functions, then you give it a repository image, and it will do the same thing. But this time it pushes everything. It creates the image, and it pushes it up to the ECR repo. All right, that's SAM package. So with SAM deploy deploys our update serverless applications on AWS. It creates and manages S3 bucket. It'll create and manage the ECR repo for you already. This is really handy. You don't have to create an image or an ECR repo. You don't have to create a bucket. SAM will handle it for you. With the S3 buckets, it's one per region, and all your artifacts are stored there. With ECR, it's a little different. It's one per application. It'll be done as a companion stack. And then once it's done, it saves all your settings to a config file that it will reference the next time you deploy, so you don't have to fill it all in again. So let's look at what it's like to do a SAM deploy guided. Okay, so this is a command. I'm going to do SAM deploy -- guided, or just -g. And what happens is the first thing it does, it says, does a config file exist? Nope. And the name of that file can be anything you want. We always look for default samconfig.toml. And then what it does, it asks you the stack name, what region you want to go to. Do you want to confirm your changes? When SAM does a deploy, the first thing it does using CloudFormation is it builds a change set. If it's a new deploy, then a change set is everything. But if it's an update, then it's going to say, of these 10 resources, I'm going to change these 3 based on your settings here. So that's a change set. So what it asks you is, do you want me to verify that change set with you before I deploy it? In this example, I push yes. Normally I default to no. Then it'll ask you, SAM needs permissions to create the roles required to do this. The default's to yes. If you don't give a permission, it kind of ends the game, because SAM needs permissions to handle that for you. All right? So then it asks you, do you want me to save the files to a configuration file? Do you want to use this same config standard name? And do you want default environment? You can set multiple environments. So I can have a default environment, a staging environment, and a prod environment, all in my SAM config with different settings. Okay. Now these are settings and configurations, not secrets. Okay. So important to know that. All right. So what it does, it looks to make sure that the S3 bucket is there. This is when doing an image. And then it uploads the artifacts, it saves arguments to the config file, and then it does the deploy, right? Now, this is just partially, it's getting it all ready. This is what happens with an image. With a container, it will then go through and it says, oh, wait a minute, you're not using S3 to manage these, you're using an ECR. So instead, what we're going to do is we're going to ask you, do you want us to create a managed ECR repository for all functions? And you can say yes or no. If you say yes, it'll create it, and it'll upload it. Okay, and at this point, zip here and container here are at the same spot, right? So what happens after that is it'll tell you, okay, now that I've got everything up there, I'm going to deploy with the following values, and I'm going to create the change set. This is what the change set looks like. In this particular one, it's a brand new deploy, so it's adding everything. There are no updates, there are no ignores, anything like that. So as I asked it, I said, do you want me, it asked if I want to verify. Yes, I want to verify. So it says, do you want to deploy this change set? Once I hit yes, it'll go through that. Now again, I usually do no on that because when I'm using SAM deploy, it's going to a development environment. I generally don't SAM deploy to my production environment, so I don't need to see the change set. But if you are, it's a good thing to look at the change set, because that will catch errors maybe you missed. Okay, so once the deployment is finished, then in this particular stack, I had some outputs, and it's that URL for the API that we changed. So it gives me a report. Hey, here's your output. You called it API URL. Here's the endpoints you can hit. You can pass on to others. And there you go. I've successfully created or updated the stack. And the name of this stack is using SAM in US West 2. The last thing it does, well, actually it did it earlier, but the last thing I want to show you is the samconfig.toml file. And you can see in here that it's got default deploy parameters. So it's got the profile default, and then the default deploys the command, and the default deploy parameters. This is how toml is configured. And it says the stack name will always be called using SAM ECR. This S3 bucket is here if that was using S3 bucket. The image repositories, you can mix and match. Some functions can be zip, some can be image. So you may have both in here like I do. Now, you can do a lot more with this. This is just for the deploy command. What if I'm using the build command? Do I have that kind of configuration? Or do I have that kind of memory? Can I have it save different settings? Yes, I absolutely can. In fact, I wrote a blog on this. If you go to s12d.com/samconfig, this will teach you how to really make development more efficient by setting up your samconfig.toml file with the default settings that you like to use. All right, so that's it for SAM deploy. Let's take a look at SAM local. SAM local is the local development, local testing, those kinds of things. And it provides, like I said, local development tools for service applications. It does run Docker to do it. And then you have multiple options. And we'll talk about these options here. The first is SAM local generate event. Now, have you ever been sitting down, if you're using SAM already or just serverless in general, and you want to invoke a lambda function and you're in the code for the lambda function and you're saying, look, an S3 bucket is going to invoke this, but I have no idea what that event is going to look like because it differs based on the service, right? And you go, I don't know what that's going to look like. Well, that's where SAM local generate event comes in. I can say SAM local generate dash event space S3, and then I fill in some other options. You can always do help to find out what those options are. Then I get an event that looks kind of like this. Now I've got some of it blocked out just to show the main part because the events are pretty large, and it could be a record. It's an array of events, so it could be more than one. And this is an S3 event. It says here's where you get the bucket. It's under S3 bucket.name, right? That's where I get the name. Or if I want the key, so there's different information I can get. So that's what the event looks like for an S3, and you can get them for batch, for AppSync, for Lex, recognition, S3, so on and so forth. So a lot of things going on here. So that's how that works. The next function of SAM local is SAM local start API. Now, SAM local start API allows you to test a lambda function as if it were being invoked through an API gateway. It emulates API gateway, and it reads whether you've got a REST API or an HTTP API, but I clearly want to make sure you understand that this is not a full-blown copy of API Gateway. This is an emulator. It will not do everything API Gateway does. It will not do authorization. It will not look for keys, things like that. It simply is a proxy style that passes the proper event and request or event and context to the Lambda function so that you can test it. So I can hit SAM local start API. It exposes the endpoint. You can see that here. And then I can test against it. And if I do a curl against that in /products using a get, I can then what happens is SAM fetches the proper Docker container if it's not already installed, and then the Lambda function's invoked through as if it was through an API gateway. And there you go. And if I have multiple Lambda functions that are all connected to the same API, they'll all be exposed. So maybe you have a get and a put on the root or on products here, or a get and a put and an update. They'll all be exposed, and you can test each one of them. This is great if you have a local client. You can point it to this endpoint to test it. Start API just sits there and listens for the call. And there's a couple of commands that make this work really well. With Start API, these work to help you pass environment variables, debug paths, log files. I encourage you to check out the documentation to see all the options. And I talk about this again in that blog where I talk about using the samconfig file. A lot of these options are in there, and I show you how to always keep warm containers and different things like that. All right, so the next one is Start Lambda. Now, previously we started a service that made it as if you were invoking a Lambda function through API Gateway. This does it as if you're invoking it through the Lambda service, but it keeps the service up and running so you can continually test it. Now, you can test this using the AWS CLI. So if I do the SAM local start Lambda, it again exposes an endpoint. And I can do the 127.0.0.1 3000. This is 3001. It takes the available port, and I can pass that through AWS Lambda, the AWS Lambda invoke command. And this is, now notice I am pointing to that endpoint. I do need to declare that I'm pointing to that endpoint, or this will try to look for that function name in your production account or in the account that you're tied to. I also tell it not to check for SSL. And then I output the responses to a .text. And you can see here, much like the Start API, it fetches the proper Docker container, and then the Lambda functions invoke locally, again, via the Lambda API emulator. All right, so some helpful ones, much like with SAM Start API, you pass environment variables, you can work with the Docker network, debug, log file, different things like that. All right, so the SAM local invoke Lambda. Very similar to Start Lambda, only it's just a quick invoke and it goes away, right? So you don't even need to use the AWS CLI. It's going to invoke it, and you can pass an event to it, and it directly invokes the Lambda. And these are great for, hey, I just want to see if my code works. Is this throwing an error? And you can get logging out of this to see, you know, what's happening here. Where's this blowing up? And you could pass in the function name. You can pass an event in. So you can remember earlier when I was showing you the structure of the SAM file, it showed an event folder, and you can pass that in. You can pass an event structure in as a file. Now, one thing I'll explain on build, as we've been talking about, or on local, is it's build aware. So what that means is when I do a SAM build, it creates all the artifacts and stores them in a .aws-sam folder under build. And everything I need is there to deploy. And that's where the Lambda function will be deployed from if you do SAM deploy. Now, when I run SAM local is going to check to see if .aws-sam exists, and it's going to use the manifest or the template.yaml from that file, which points to this hello world function under the build folder. If that doesn't exist, then it'll use the root one, which works for things like Python or Node, which are mainly the languages I work in. But it won't work for like a .NET or Java because they're not compiled at this point. Now, what happens to me is I will do a SAM build, I will test, find out that my function's not doing what I want it to do, update the function, run the test again, and the changes aren't in place because I did not build my code again. And then it takes me 20 minutes of banging my head against the wall to figure out, I didn't build my code again. So build your code, right? Or delete the folder. Either one of them works. Don't edit inside that folder. It'll get overwritten all the time. All right, another function as part of SAM, and this is not in local, this is just on the root, is SAM logs. SAM logs allows you to you just turn on SAM logs. You can pass it either a physical name of a Lambda function or a stack name and a logical name of a Lambda function, and it'll read the logs, and you can tail that. So you can do a tail being TAIL, and it'll just, as you're going against that, you can pull logs, and it will read directly from CloudWatch. And there's some helpful options for this. You can filter, so you can say, look, I just want ones that say this or that, or I want it from just this start time to this end time, or they're logically, you say from 5 minutes ago, and then like I said, you can use the tail feature. All right, so we've talked about deploying from SAM, but really we don't do that all the time. When we want to deploy to production, we generally use some type of CI/CD, and we get a lot of questions about how do I create a CI/CD for serverless. Well, we've got you. We're going to help you out here. We've just come out with a new feature this summer called SAM Pipelines. And SAM Pipeline generates resources and configurations to build a CI/CD for you. And it supports, the AWS Code Suite, which is Code Pipeline, Code Build, and so on. GitHub Actions, Jenkins CI, and GitLab for now. We're adding more all the time. Now, how this works is the first thing you do is you're going to run SAM Pipeline Bootstrap. And this is going to generate the required AWS infrastructure for one stage, right? And for each stage, so let's say you're going to do a two-stage deployment. So let's say, let's say beta and production. For each stage, you run SAM Pipeline Bootstrap again, and it'll go through a configuration. And here's what that looks like. So I'll do the SAM Pipeline Bootstrap, and I'll go through and I'll answer some questions about what I'm doing. And specifically the account details. What account are you going to be using? Will this be in what region? Those kinds of things. And then it'll tell me, hey, I'm going to associate this account with, and I've just got a dummy account ID in there. And then you put the region in. And then it's going to summarize what it's going to build for you. Okay, and it says I'm going to do all these. You weren't using images, you're using zip. Based on all that, this is what I'm going to do. So let me create these resources. When the resources are created, it's going to kick out a set of credentials, and it's going to kick out a set of instructions on what to do with those credentials based on the client you're going to use. All right, so you have the credentials created and the instructions. Grab those credentials, right? Grab them and save them because you can't get them again because they're secret. All right, so grab them and save them as you need it. So the next thing you're going to do is you're going to do SAM pipeline init. So remember, you're going to run the bootstrap for as many stages as you want. Now you're going to run init, and this is going to generate the pipeline for the specific client you want to use. So let's look at that. So the first thing it's going to say is, hey, you SAM pipeline, what do you want to use? One of our quick start templates, much like SAM, the SAM init itself. And then we can do custom or your custom. So we're going to choose one of their built-in ones. And in this, I'm choosing GitHub Actions. So the next thing it's going to do is say, okay, you're using a 2 pipeline stage template, and I've built those 2. And it's going to ask me, what is the GitHub secret name? So because in those instructions from the previous step, it's going to tell you how to set it up, and this information will be available. Then it's going to say, is this beta or prod? And you'll set up each one. So my first one would be beta, my second one would be prod. And then it's all configured. When everything comes out, you're going to have, it depends on the client that you choose, you're going to have the workflow configured. So this is actually the .github workflows pipeline. So when I commit this, then I automatically have a pipeline ready to go in GitHub. So GitHub Actions. So every time I commit a new commit or more code, then it's going to run that deploy for me. So there's a lot of flexibility with this, and you can change it out. So I encourage you to check this out if you're struggling to build a CI/CD pipeline. The next one we have is SAM delete. And this is the last command we're going to talk about. It's fairly new. And when you're wanting to tear down your stacks, do it this way. SAM delete is aware of any companion stacks that it's building, of any resources it's building. So it'll delete everything, and you won't have any companion stacks left hanging around. So be sure and do SAM delete, and it'll ask you some questions. You sure you want to delete this? You sure you want to delete that? It's very, very handy. By the way, I've been talking through a lot of this, and a lot of these features apply not only to SAM, we've talked about SAM, but also if you're a CDK user, we are running a beta test where you can do AWS CDK with these SAM local things like build, invoke, start API, generate events, so on and so forth. And you can see that and learn more about that at s12d.com/SAM CDK. All right, we've covered a lot. We have just a few more minutes. I hope you're hanging in there with me. In this last part, we're going to talk about SAM Accelerate. Now, here's what we know. We know that developers have been trying to emulate things locally. All these emulations have been built, and we feel that instead of trying to bring the cloud to your account, to your computer, we want to get developers to the cloud. But we know that deploying after every change can take a while, and it's slow. So we're working on a new set of features called SAM Accelerate, and it's really this collection of features. And here's what it means. AWS SAM Accelerate aims to increase infrastructure accuracy for testing with incremental builds, SAM sync, and aggregated feedback for developers. Now, what do I mean by infrastructure accuracy? Well, like I said earlier, we see so many folks that want to build and they try to emulate so much in the cloud. But what we encourage is emulate as little as possible. And with SAM local, that's what we're encouraging. Pretty much API gateway and lambda. There's also a local version of state functions if you need to use that. But those should only be used for unit or function level testing. Run those, iterate against those till it's working, and then test everything else in the cloud. Quit bringing emulators to you. They're not accurate. A lot of the emulators we see are behind and they're not accurate for what we're building. So we encourage you to test in the cloud as often as possible. All right, so the first thing we're going to do to speed this up, like I said, we know that deploying can take a long time. So the first thing we're going to do is, or building and deploying, is we're going to make building faster. Okay, currently, when you do a SAM build, regardless of the language you're doing, it will update all the dependencies and the code and get everything together. Now, it's fairly fast, but sometimes you have a lot of dependencies, it can be kind of slow. But it's all cached, right? But now, what we're doing is we're saying, with this change, we're doing incremental builds, and we're saying only the deltas or only the changes you've made will be built from now on. So we won't touch the dependencies. Those will be cached for you unless you change those. So we'll only change the code. And that's probably going to be 90% of what you're doing. You get your dependencies set, and then you're iterating against your code. So they'll build very fast for local testing, right? Now, let's talk about syncing with the cloud. How do we get out to the cloud fast to test in the cloud? The next thing we're doing is we're building a function called AWS SAM Sync, or a command called SAM Sync. Now, in order to understand SAM Sync, we first want to divide between code and configuration. SAM Sync is going to define code as Lambda function code, Lambda layer code, step function Amazon States language, and API gateway open API. You'll notice throughout this presentation, I've been showing you to use open API or AWS States language to configure API gateway and step functions respectively. When those are separated out in different files, SAM can differentiate those, and everything else is considered configuration. And so when we use SAM Sync, it's going to look at this specifically and work a specific way. So let's take a look at this. A couple scenarios. So let's say right now, anytime we do a deploy, you always have to do a full update, right? And CloudFormation's smart enough to only change the things that have changed, but create change set, do the deploy. It takes a while. It can be in the minutes, right, while you're waiting. But with this change, what we're going to do is if you make a code change using SAM Sync, if only the Lambda function is changed, then only the Lambda function gets pushed. And it does not do it through CloudFormation. It does it directly with the service. So we're talking a matter of seconds, right? And single digit seconds to see that code update. So rather than me iterating locally all the time, if I make a change and I save it and I do a SAM Sync, then it's ready to go. I can test in the cloud. That means my permissions are going to be correct. My architecture is going to be, well, if you did it correct, they're going to be according to what you have set it up, right? So the same thing with ASL. So if you have a separate ASL template and you're updating your step functions, then that's all that gets pushed. It's a quick push to say, let's update this, and that's it. Everything else is left alone. But what about event bridge configuration? Well, that's a configuration. So we're going to do a stack update that changes just those configurations. Finally, an open API update. If I change open API, that's all that's going to get pushed is just that template. Now, like I said, with that open API, you want to make sure it's separate and in its own file, and it looks kind of like this. So open API example to kind of understand that. So we do that, we make a change to that, and it'll do a quick update of that code. All right, so what if we change the Lambda configuration? What if we change the timeout? Well, that's a configuration change, and it'll do a full deploy. And finally, what about a Lambda layer? Lambda layer is considered code. You're changing the dependencies of the code, so it'll update the layer itself, and that's a quick change, so you can test against that. It'll update the layer and update the Lambda function to point to the new version of that layer. So this is available with SAM Sync, and then you also have the ability to do SAM Sync Watch. All right, and there's actually several commands with SAM Sync. You can say SAM Sync infra, SAM Sync code, so you can separate between those as you want. But SAM Sync Watch does the magic automatically, and as you code, it'll watch for changes, and if it's a code change, it'll do the updates like we talked about. If it's a configuration, it'll do a CloudFormation update. All right, so the last thing we're going to talk about real quick is aggregated feedback to developers. Aggregated feedback to developers, I showed you SAM logs, how it could grab from the logs for an AWS Lambda function and bring that down. We're going to beef that up. First of all, it's going to grab from CloudWatch and X-Ray. So you get traces and CloudWatch logs for your Lambda function. But we're also going to include API gateway logs. So you get a full set of logging to see how things are working through this. So don't limit that. And you can SAM logs tail, and you tell it what you want, include X-Ray, don't include X-Ray, and you'll get a full amount of information on that. Now, right now, like I said, this is in beta, but it is at a point where you can test it, and we're going to be probably by the time this shows, it should be out with a binary. So we're this is a little secret, but you can look at a lot of this on our SAM CLI roadmap. We have opened up the SAM CLI roadmap to show everything we're building on this. You can give us pluses and minuses. You can even help because it's open source. So we really encourage you to get involved with this and and plug in and help us drive this. The other resource I would tell you, a lot of the same stuff I'm talking about can be dug further into on serverlessland.com. This is a website that my team maintains, and we put everything we do. You'll find this video on there at some point probably. And finally, Sessions with SAM. This is a series I did last year where I went in depth. There's more than 20 episodes where I go in depth into all kinds of stuff on SAM. The videos are the s12d.com/sessions with SAM, and the code examples are sessions with SAM -repo. So great way to get started. One more thing I want to say about the serverless land. We have a thing called serverless land patterns. If you're looking to get started and don't know how two services can integrate, you can go to the patterns and say, hey, I have S3 bucket and a lambda, give me an example, and it will give you the example, and it's in a SAM template already, so you can copy that SAM template and drop it into your application. With that, I want to say thank you. Again, my name is EDJ Geek. You can reach me on Twitter. We went through a lot, but now I'm going to open it up to Q&A, and I'll answer all the questions I can. Forgive me for going at lightning speed, but I hope you got the information you need to kind of get your appetite wet to see what else you can do with SAM. Thank you so much. Have a great day.